Okay, I just wanted to go through the answers to some of our Wednesday, day 5 discussion questions. So this is the one about the forester who measures 27 trees and finds a certain standard deviation and a certain mean for that distribution. And so the first question is it reasonable to assume a normal model? And what we mean by that is it appropriate to use a normal model to estimate how many or what percentage of trees lie in certain ranges? So the normal model, as we said, is never going to be exactly correct. This question is asking, is it reasonable to use this model? And you could sort of go either way with this one. So some reasons to not use it would be that we've got a very small sample size, so only 27 trees is certainly on the low end. And another reason would be that because any use of a normal model is always going to have some percentage of the distribution less than 0, as we'll see on question 4. So it's always going to be a little bit inaccurate. However, for the most part, we would expect things like measurements of trees, a lot of measurements in general usually, are going to roughly be symmetric, going to be unimodal, and in those cases, using a normal distribution model is actually reasonably accurate. So for this purposes, yeah, a normal model is going to give us a reasonable sense of what this distribution looks like. Okay, so that's question 1. We also want to draw a normal model by hand and label the axes. So I saw a bunch of people draw these, and a few of them were pretty decent, but obviously it's not easy to do by hand. It's a lot easier if you have a stylus or something. Okay, but anyway, here is my normal model. The mean, which should be right in the middle here, is 10.4 inches. And then let's label a few more points. So 1 inch would be over here. So that's 2 standard deviations below the mean. 5.7 is 1 standard deviation below the mean. And then we've got 1 standard deviation above, 2 standard deviations above. Cool. Anyway, so this is a picture of our guess of what this distribution looks like. Let's see. We also want to know, for number 3, we want to know what size we expect the central 95% of the trees to be. Well, the 68, 95, 99.7 rule, the 95 part of that is saying that 95% of the distribution should be within 2 standard deviations of the mean. So as I said, we've got our mean here. This is 1 standard deviation. This is another standard deviation. So 2 standard deviations is the range from 1 to 19.8. So we would expect for number 3, the sizes that we would expect 95% of the trees to be is 1 inch to 19.8 inches. Question 4 was somewhat of a trick/discussion question. What percentage of the trees are less than 0 inches? Obviously, none of them are less than 0 inches. You can't be less than 0 inches. But the normal model is going to tell us that some percentage is less than 0 inches, because this distribution always sort of goes off and goes infinitely wide. There's always going to be some percentage predicted by a normal model to be in an impossible range, so it'd be less than 0. So this question was sort of saying, like, all right, what percentage is that? And we can find that by saying that, all right, well, what's the z value? All right, so the z-score is going to be 0 minus 10.4 over 4.7, which comes out to 2.2. And so we want to know what the area of this region is, everything less than that cutoff. And we can find that by using p-norm in RStudio. P-norm of 2.2 should be approximately 0.013, so about 1.3%. So the model is saying that about 1% of these trees should be less than 0. So that obviously can't happen, But this 1% is a relatively small proportion, and our model is going to be a little bit off. It's sort of okay for it to be that much off. 1% is definitely on the high end, but it's sort of, it's one of those things that it's close enough. The normal model is never going to be completely accurate. This is, still reasonable. Okay, so the last question is, what percentage of trees are over 15 inches in diameter? Well, we want to know, so 15 happens right about here. We want to know what this area is. So we can find the z-score for 15, and then plug that into p-norm, and we're gonna want to do 1 minus that. So the z-score for 15 is 15 minus 10.4. Okay, so the z-score ends up being approximately 1. I got 0.97, rounding 0.979, and we can run p-norm of this, which is going to tell us what the area of everything to the left of this cutoff looks like. Well, if the total area is 1, then 1 minus the p-norm of this should tell us the area that we actually want. So by running that, we see that this comes out to be, I think, 0.836. So the percentage that we actually are looking for is 1 minus that, or 0.164. So about 16%. It's worth pointing out that we can also do this in a more estimating way. We can use that 68, 95, 99.7 rule again. So this is a second approach to question number 5, and that is by recognizing that this region constitutes 68%. So let's actually use another color here. So if this is 68%, that means that this region is going to be, well, half of 100 minus 68. In other words, this is going to be 32 over 2, which is approximately 16%, which is sort of the same answer.